Hey y'all, in this lesson, we're going to be learning about probability when you see the word and in the problem. And this is going to relate to my lesson on conditional probability. So if you haven't learned that one yet, then make sure you go in and view that first. Let's first recall from set theory that the word and represents the intersection of two or more sets, sorry. So for probability, let's now, take that and talk about what we're going to do here. So I did mention that you're going to have to know about conditional probability in order to do this. Basically, this formula here applies for any two events. Whenever you see the word and, you can always use this formula. So it's kind of a fail-safe. And then if you know that the two events are independent, then you can just multiply the probabilities of each event together. You don't have to worry about conditional. I talked about independent events in my last lesson with conditional probability. So if you need to go back and view that, go for it. But this is kind of your fail-safe. And then this is if you know it's independent. So I have a table here. Hector is organizing his books. He's placed them into the following categories. We have fiction, nonfiction, hardcover, paperback. We can see that there's some overlap here. Hardcover fiction, hardcover nonfiction. Man, that's hard to say. Okay, so we're going to use this table to help us practice using the formula of A and B, or in this case, F and P, I think. So find the probability of drawing or grabbing a paperback book. So if we are just talking about the probability of paperback books, then we can focus on the totals here. There are 12 paperback books out of a total of 20 books. And then you want to reduce to get 3/5. So 3/5 of the books are paperback. And then find the probability of fiction given that it's paperback. I'm going to start this one with the formula. And if we're using the formula, we have to do the intersection. Whoops, I used the wrong letters. F, fiction and paperback, and then the probability of paperback. So the probability of the intersection of the two, fiction and paperback, is 7. That's where they overlap. 7/20 is the probability. And then the probability that it's paperback, we already found in the previous example, was 12/20. And then if we flip it and multiply, we get 7/12. And then the last one, the probability of paperback and fiction, and we're going to use the formula. So the formula refers to this guy up here. Probability of paperback and fiction. So we have to do probability of paperback times probability of fiction given paperback. So I'm just kind of subbing in the letters where they go in the formula. We know that the probability of a paperback book, we already found, was 12/20. You can do 3/5 if you want to. I'm just going to leave it not reduced for now. Yeah. And then the probability of fiction given paperback, we found 7/12. And so now here you can see why I didn't reduce it, because these are going to divide and we get 7/20. Now that we've used the formulas, so you know the mathematical way that we found these numbers, I want to go back over B and C using some logic techniques. So kind of using common sense here. We already talked about in the previous video that when you're looking at conditional probability, that the second letter becomes the new universal set, the new sample space of total possible outcomes. So if I'm trying to find fiction given that it's a paperback, then that means I am focusing on paperback as my universal set. It's not really the universal set, but for the sake of this problem, we're going to consider it the universal set. And I'm trying to find the probability that it is fiction within that. So if I were to just look at that in a common sense way, I could say 7 of the 12 books are fictional paperback. And then likewise for part C, which is, I got 7/12, so it checks out. And then likewise for part C, probability of paperback and fiction. You may notice that the intersection of paperback and fiction, we already saw, is 7. And then the total number of books out of all the books on the bookshelf is 20. And then there's that 7/20. So I would just be careful if you are going to use common sense and just viewing the table. I'll be very careful about being able to differentiate between conditional probability and when they use the word and. So conditional probability is kind of changing that denominator, that universal set. And then when you see the word and, we're using the actual universal set. So my words are getting sloppy there, but hopefully that kind of makes sense to you. And if it doesn't, if that confuse you to just use the table to figure those out, then go ahead and lean on those formulas. Get comfortable with those formulas and just use them because they're safe. The next example is one that I was kind of talking about in the last video where I was discussing independent events. And I mentioned that events that the next event depends on the first one, then those are dependent. I said it in the wording, but like if I have a deck of cards and I take the card out and I keep it, then for my second draw, that second draw is going to be affected by the first draw because I'm missing a card. Now, if I take that card, I look at it and I put it back, then the second time I draw, I have the same chances. So this is an example of down here. Let's read it. Brooke is drawing marbles from a jar. She wants to draw 3 marbles without replacement. And that is important because that means that when she draws a marble, she's going to keep it outside of the jar. She's going to keep it in her hand, which means that the next time she goes and gets a marble, now there's less marbles in the jar, which changes the probability. So these are dependent events. We want to find the probability that she draws a red, then a blue, and then yellow marbles in that order. So for the first draw, if we're just looking at red marbles, there are 4 red marbles out of 11 marbles. And means multiply. The probability of drawing a blue marble, there's 2 out of, now if she drew a marble, it doesn't matter what color it is. If she drew a marble, then, and she kept it out because she didn't replace it, now there's only 10 marbles. And then and means multiply. Probability of drawing a yellow marble, there's 1, 2, 3, 4, 5 yellow marbles. And again, there's 1 less marble because now she's pulled out 2, so we get 9. And means multiply, so now we're just going to multiply straight across for our answer and then reduce. You should get 40 over 990, and then that's going to reduce to 4 over 99. So that's a really low chance. Now we're going to find the probability that she draws 2 red marbles and then 1 blue marble in that order. So for her first draw, she wants a red one, and we know that there are 4 out of 11. And then for her second draw, she wants another red one. Let's assume that she pulled out a red one in her first draw. So now we have 3 red ones left, and now 10 total left. Last one, blue. There's 2 blues, 9 total, and then multiply straight across and reduce. I do want to point out if you're having trouble reducing and if you're allowed to use a calculator, how you can use that to your advantage. I'm going to pull up a calculator here. I'm going to type in 24 over 990. And I'm going to go to math. That first option is fraction. Enter, and it reduces it for you. So there you go. We should get 4 over 165 there. That's all I have for this lesson. In summary, when you see the word and, you're going to be multiplying the events, but also you need to take into consideration that that denominator might be changing if the events are dependent, and sometimes even that numerator changes. So be careful with that. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help. See you in the next one.